Combustion measurements are essential for a variety of industries, from process control, environmental, reliability, and safety standpoints. Yokogawa currently offers excellent tools in the form of the TDLS8000 for measuring oxygen, CO, and methane. The issue with that platform is that you can't measure all those components in one single device, and they require two opposing flanges for installation, which makes brownfield installations not always economically or mechanically feasible. The new TDLS8200 addresses both of those issues by combining the O2, methane, and CO measurements into one device with a one-flange installation. This makes direct replacement of legacy single-flange analyzers much more easy and economical.
Most spectroscopic analyzers have all the optical elements outside the hot process, protected by isolation windows. Only the optical radiation crosses the high temperature region. TDLS8200, to the contrary, has optical elements immersed in the process to ensure folded optical path with single-ended insertion. That brings along several engineering challenges. Immersed optics must be protected from dirty and aggressive processes by clean purge, putting forward gas mixing problems. Vibrations of the probe end can disrupt the optical alignment. Fitting optical paths of the true lasers within a standard 2-inch pipe took some creativity too. On top of that, our engineers successfully addressed heat load and crosstalk issues in electronic schematics.
There were 2 points of design which I found to be particularly interesting. The first interesting point was how to maintain a compact design with 2 sets of optics, and we did that via optical simulation to optimize the alignment of parts. The second point dealt with the heat generated from combining both sets of measurement components to maintain the same ambient temperature specification and precise laser control via modification of the mechanical design. It was a rewarding feeling during performance testing that our development efforts successfully yielded a device that could measure oxygen, CO, and methane simultaneously.
The TDLS8200 needs not only to be reliable but also safe, robust, and easy to install. By designing the TDLS8200 to meet SHIL for functional safety and certifying it for many regional explosion-proof, flame-proof standards, we've created a product that can be used in safety systems across the globe. Even the alignment mechanism, which functions internally, can be adjusted while still maintaining an explosion-proof structure. We've done our best to integrate the best solutions into the TDLS8200.
Previously, to realize the benefits of using a tunable diode laser measurement, you had to use 2 separate devices to monitor all combustion parameters. But now, you can measure the key combustion parameters of oxygen, CO, and methane with a single flange device. This allows you to economically take advantage of cutting-edge technology via direct replacement of legacy technology devices. It's truly a game-changing device. Customers can incorporate the device into control, monitoring, and/or situated safety measurements for oxygen, CO, and/or methane. Previously, multiple analyzers would have been required to accomplish the same measurement objectives, which are costly to install and maintain. This is the value in using the TDLS8200 from a long-term perspective.
The TDLS8200 houses all the industry-leading features in a single-flange, explosion-proof device for combustion measurements for measuring O2, CO, and methane. Whether it's being used for O2 trim control, CO monitoring, high combustible fuel runback control, or even a SIL2 rated startup permissive for methane, the TDLS8200 is capable of providing all of these measurements in a single device.